Hello, and welcome to the Smart Academy, the Smart Family Cooling Products. Today, we're going to do an introductory lesson on characteristics of air or air quality, and a very brief introduction into the psychrometric chart. Now, the psychrometric chart can be a little bit scary for some people that are not familiar with it. Don't worry, we're going to break down each step, and it'll be very straightforward at the end of this video. Okay. To start, let's talk about temperature. If I were to tell you what temperature it is in this room, I would do that normally by looking at a thermometer, let's say an old mercury thermometer. I would look at the temperature and I would tell you it is what, 70, 80 degrees, whatever it happens to be in the space. So I happen to have a temperature sensor here. This is used on one of our Smart Family training modules here. We have a little controller that we use on our air conditioning units. So this is measuring temperature. And the temperature in this space is 79.5 degrees in Fahrenheit scale. And we would actually say that that's the dry bulb temperature. Normally when we're talking in groups of people and we say the temperature in the scale, we're talking about dry bulb. So this air is currently 79 degrees Fahrenheit, dry bulb temperature. If I wanted to go to a Psych chart and show you how that's represented on a Psych chart, let's start by looking at the chart as a whole. There's a whole bunch of curved and straight lines on the psychrometric chart, and we're going to start by explaining dry bulb temperature. Dry bulb temperature are these long vertical lines on the chart, and we said that it was 79 degrees Fahrenheit, so 75, 6, 7, 8, 9, 79 degrees Fahrenheit. If I wanted to represent 79 degrees dry bulb temperature on a psychrometric chart, draw the line all the way up and down the chart. So why did I draw this long vertical line? Well, when we're communicating temperature, specifically when we're talking about heating, cooling, air conditioning, or dehumidification applications, there's always a second component to air that we always want to bring into the discussion, and that's moisture content, or how much energy that particular volume of air can contain. The most common way that we represent the moisture content of the air is going to be in percent relative humidity. So if I said this space is 79 degrees and we're in Houston, so it's relatively humid, so 60 to 70% relative humidity. If I gave you that as a starting point, you would know the good characteristics of the air, and from there we could do a lot of cooling, heating, dehumidification calculations with that information. But let's go in a little bit more detail about the moisture content of the air. So percent relative humidity is fairly common. Another way that that same measurement can be described is in wet bulb temperature. So currently we have another sensor. It's been totally submerged in water that's fully saturated. So the air in here obviously cannot contain any more moisture because it's a full bottle of water. And you'll see that that temperature is 74.8 degrees. So the air temperature was 79 degrees, and the wet bulb temperature here is 74.8 degrees Fahrenheit. So if I wanted to know the characteristics of the air in this room and I wanted to plot it on the Psych chart, I would have to find 74.8 degrees Fahrenheit wet bulb and then 79 degrees dry bulb. Well, I plotted our 79 degree dry bulb, so now all I need to do is find our wet bulb temperature. Wet bulb temperatures are going to be these diagonal lines going across the chart. And we said we were at 74.8, so we see 70 right here and 75. So we want 74.8, I'm going to say about 80% of the way between 74 and 75. Draw a line. All the way through the center. Where those two lines meet, our percent moisture and our dry bulb temperature, is going to be the actual conditions of the air we're in. So actual conditions of the air right here is 79 degree dry bulb temperature and 74.8 degree wet bulb temperature. If we wanted to say that another way, we could look at our relative humidity lines, which are these arced lines going through the chart, and we could determine by where our plotted point is what percent the relative humidity is in this space. And you'll see This is 80 and 90, so 80% relative humidity and 90%. I would say we're somewhere towards the 82% relative humidity level. Why? Well, it's Houston and it's been raining on and off, and so this is a shop space, so it can be fairly humid. Okay. So we can represent the same point by saying 79-degree dry bulb and 74.8-degree wet bulb, or 79-degree dry bulb at 82% relative humidity. We're saying the same thing. There's other features or other ways we can represent that same point on the Psych chart. If I draw a horizontal line through our point, you'll see we have more numbers here. This is actually the moisture in grains of moisture per pound. And our particular point, I would say it's right around 124 grains of moisture per pound. When we go through more in-depth videos, we'll talk about what that really means and how does that equate to calculating dehumidification capacity. If we continue to look on the chart, you'll also see that you'll find dew point temperature and a whole bunch of other items that we can extrapolate once we know how to plot a particular point on our chart. So we're going to start with that single point, and from here we'll talk about cooling and heating capacities in later videos and how we go through the process and how we know how to calculate how much cooling or dehumidification we're doing by using our psychrometric chart. Thank you, and continue watching for more videos.